Hello, welcome. My name is Ben Curry, and this is Wayne Ewington.
Okay, cool.
And this session is your mic working?
I don't think, sorry, my mic's not
very
working.
good.
Cool.
And you are in the Optimizing and Maintaining SQL and SharePoint Databases session. So a little bit about me, and then we'll go to more about him. I am from the U.S., just west of Atlanta, if you know where Atlanta is. And some of you know my books from Microsoft Press, O'Reilly, and I write blogs occasionally, but do primarily consulting. So I spend a lot of time building SharePoint, and in about 7 years now, that is all I've done.
Okay, so my name's Wayne Ewington. I'm from Microsoft New Zealand, from New Zealand. So I'm the one here that doesn't have the accent. I just want to be clear about that. The rest of you have got funny accents. I've been working for Microsoft for about 11 years, just over 11 and a half years, primarily working in the SharePoint space. In fact, my history of SharePoint goes right back to the Tahoe and Encompass Resolution version 4 days. So anybody know what Tahoe was? Anybody want to make a guess? A few people? Anybody want to call it out? Rubbish. It was a bit of rubbish. Yeah, it was SharePoint 2001. Anybody know what Encompass Resolution version 4 was? Anyone? I know a couple of guys. Yep. It was indeed. So Encompass was a company based out of Canada that Microsoft acquired. They had version 4 of their product, which was Resolution, and that became Microsoft Content Management Server. So basically I had a bit of a love-hate relationship with regards to SharePoint. So I used to really love doing content management server work, and I had this thing there which was SharePoint. And so when the content management server product got merged into the Office team, became part of SharePoint, I kind of gave up and decided to apply myself more into SharePoint. So basically to the point where I decided to do my master certification. It's a bit of a mouthful. And then last year decided to do the architect certification as well. My email address is actually up there, even though it is a little bit hard to read. So if you do have any questions, don't hesitate to ping me an email, and I'll do my best to answer that.
And I can tell you from preparing the session with Wayne, he is one of the smartest SharePoint people I know. So I may say less and let him say more, and we'll bring hopefully some real-world experience into this demonstration as well.
Okay, so now I've got a bit of pressure on me. Okay,
yeah, you're welcome. Anytime. Yeah, whatever I can do.
Okay, cool. So what we're going to do is that these next two talks are basically broken up into going through designing and architecting, then deploying, and then going through and maintaining and operating. This is primarily from a SharePoint and a SQL perspective, okay? So we're going to look at how do you actually go through and design and architect SQL from a SharePoint perspective, how do we go about and actually deploy it, and then how do we go through and actually maintain and operate this. So this first talk is primarily going to be around designing and architecting. Depending how we go from a time perspective, we may get into some deploying aspects, but primarily it's broken up between these two different presentations.
And there'll be a break, and then we'll continue the SQL after the break as well.
Cool. So
I pulled this picture because I wanted to stress the point that almost everything in SharePoint is built on SQL Server. So if you have a poor foundation, your SharePoint will collapse. Showing you an example here of a very nice, well-built beach house that had a very poor foundation in the sand. When the sand gave, the house collapsed. That is a good analogy for SQL Server and SharePoint. You can spend all the time you want working business requirements and getting lists and BI and InfoPath forms and brilliant code written, but if you cannot keep your SQL Server up or if it performs poorly, it doesn't matter. Your solutions will collapse. So it is foundational to SharePoint.
Absolutely. So it's really quite critical. I mean, a lot of people talk about, for example, adding additional servers into the farm. Sometimes it's probably better to add some more database servers into the farm. Okay, so SharePoint is so dependent on SQL that if you don't optimize this and get it right, your performance could actually be not that great, and you may not actually get the value out of it. So.
Yeah, there's some interesting details on adding web servers to a farm on TechNet, and you do see a decrease as you get into 4 or 5 web server range.
So what we're going to look at is go through and look at the disk subsystem. So kind of dive down into why is this actually important. Look at it from the SharePoint databases perspective as to which databases actually go well together. And then we're going to have a look at what do you actually do from a high availability and or a disaster recovery perspective as to some of the technologies that SQL Server offers.
Well, let's start down and work with a lot of SharePoint administrators who are the SQL DBA. So how many of you SharePoint are also the DBAs at your facility? That's very common. It's really common to go into a client and they'll have 5 Oracle DBAs for the Oracle, but they'll have no DBAs for SQL Server. It just seems sometimes there's almost a lack of respect.
Yeah. So the people that put their hand up, could you put your hand back up again? So out of the lots that have got your hand up, how many of you have been trained as a DBA? Okay, so quite a lot lower, which is actually quite common. So, yeah, cool.
So it's very common when we go ask the SQL DBA or the SharePoint administrators what else is running on the disk. So here I have 2 disk arrays or 1 disk array on the left-hand side. And because of storage area networks, especially when we get into SAN virtualization, the answer is often, I don't know. I don't know what else is on that disk. So we get into a poorly performing SharePoint farm, and what I like to do is actually go find the disk and put my finger, if it's in a storage frame, and then ask the storage professionals or storage team, what else is on this disk? Very recent, we had a customer with a very poorly performing search. And we'll show you Wednesday, Steve Smith and I will be doing a capacity planning, and we'll show you how to monitor for some of these performance counters. And what had happened, they had a large disk array that was also running Exchange Server. And the storage team had carved up 2 different LUNs or 2 different volumes. And so the Exchange was it's a very, very busy IO-hungry application. So SharePoint was running very poorly. It actually had very little to do with SharePoint. A better way, and at the high level how we resolved this, was by putting another disk array in and moving SharePoint to some dedicated spindles in the storage frame.
Cool.
So just a quick overview, the difference between a storage area network, which is fiber channel based, and storage area networks are more and more common today, even small ones. This is a little bit larger example here, which is very different than a NAS or a network attached storage. NAS is essentially just a file share that we're mounting up, where SAN is a dedicated storage network and it has a very, very high efficiency, probably 95% efficient, versus a NAS, which is Ethernet based, so fairly inefficient and slow speeds. So basically, at the root of the disk design, we're going to talk about how to optimize disk here for a few minutes. But if you don't know, don't make it too complex. I think there's a lot to be said in keeping it simple. So simplicity in your design. Essentially, you don't get to under-design, but you don't get to over-engineer either. There is the doing it the right way in the middle.
So you've got NAS as being slow there. How slow can you actually go?
It's about 20 milliseconds is, I believe, correct on NAS, and that's only for, is that right, blob storage? Is that right?
So on the first right. So there is a couple of guidelines around how fast does your IOPS, basically how fast does it actually have to be. So one of the boundaries that we've actually got from a SharePoint perspective is that it's 20 milliseconds on the first write for the buffer. Okay? So anything lower than that is unsupported, and that's a hard boundary, completely unsupported, which basically means you could do it on NAS, which is a bit faster than that, but it may not be a good idea to.
So I could go 19 milliseconds, and that would be okay?
That would be okay.
Not
a good idea.
Yeah. So as we talk about some of the limits in this session, you don't want to engineer up to the limits, and it is actually a common mistake.
Exactly.
That we want to bump up to 30 million documents, or we want to go up to 2 gigabyte blobs. What do you think about blobs? You said something about blobs and NAS.
Well, we're going to cover that later.
All right. So basically, a large number of small disks is usually much faster than a small number of large disks. All right, so I'll let that sink in just a second. A lot of times with SharePoint, especially get into search, user profile, very busy websites and those content databases, we will hit the capacity or the threshold on moving content on and off the disk before we reach anywhere near capacity. We had this argument with storage teams because they'll say, well, you have a 2 terabyte storage array and it's half empty, and you're telling me I have to add disks. We have to add disks to get better throughput because we need more disks to actually get more bandwidth. So It's a very interesting engineering problem, and it's very common, so we're putting in smaller disks and more of them, and increases your throughput. Essentially, direct attached storage, or DAS, is going to be the fastest way. Generally speaking, it's almost always fast. So disk that is internal to the server or attached, SQL likes that a lot. There's a fair bit of the disk actually inside of Microsoft, MSIT, on their SharePoint that is actually DAS.
So what about if you have got a virtualized SQL Server environment?
So it's a couple of, that's a really good question. If I have virtualized SQL, if possible, we like to mount the LUNs up, the volume, directly to the SQL server.
So it's probably not a good idea to use virtualized disks?
I would probably not use virtualized disk. That would be, our experience has been very bad.
Okay. So just a key point too, just around the way that SQL Server works here. SQL Server is very, very disk I/O intensive. So any database that corruptions it actually have, 99% of them are actually on the disk I/O subsystem. Okay? So it's actually outside of how SQL Server is actually working. It's right down this lower level where you actually get the read-write errors, etc. like that, which can corrupt your databases. So this is why the disk system is actually so critical, that you actually get it right, and that it's fast, and it's actually going to work for you.
And similar with network, if possible, with SQL Server virtualized, we do try to also get some dedicated NICs for large traffic. One thing to think about is why would we go to SAN? Obviously, a hosted infrastructure is very common. It's all storage area network or SAN. But also, we need things like snapshots. So something in your data center where you require high availability or disaster recovery. So essentially, we use SANs for SQL when we need the functionality of a SAN. I don't think we jump to SAN just because it's elegant or the latest thing to do. And basically on NAS, it's like the old drug campaign in the 80s, just say no. Basically, we try to avoid NAS if at all possible. So once you've looked at your disk, right, you've said, well, I'm going to get some dedicated spindles for SharePoint. We can further the design by taking a look at how we separate databases within your farm. So logically grouping databases together for like performance or like service levels. So here's an example of 3 crawl databases. Let me give you a little bit of background for this client. This was an electronic health records solution that was storing 10 to 15 million items in a library. And so it's a farm built around managing those records and getting really fast response time. So a very robust crawl. Let me give you an example of what the actual SQL storage. So these are the actual LUNs that were mounted up or divided up on the SAN. And this is what was attached to SQL Server. In the beginning, it was a single, very large SQL Server. You'll see that we've divided the content databases from the crawl databases, which are separate from, the usage app or one of these, the property and ULS files. So taking those really, really busy service applications like user profiles, search, especially the crawl. I think the crawl is probably the busiest application you're going to see for I/O on the disk.
In fact, the crawl DB is probably the ugliest, nastiest database out of SharePoint. When you're running a crawl, that thing gets hammered. Okay, so if you want to worry about performance of a search is one of your workloads that you want to concentrate on, and you're doing a lot of indexing and hence a lot of crawling, you may want to seriously consider isolating that completely off by itself.
Notice in this that the crawl database, we only have 3,500 as the IOPS, and that's the minimum requirement for the crawl. So the real world, you're between 3,500 IOPS and 7,000, which is a lot. And you will not get that on a single disk, I guess, unless you were solid state. So we'll talk a little bit more in just a second about how we get that type of throughput. You'll also notice here that we've separated the MDFs, or the data, from the LDFs, or the logs. It's a very common approach, and if you can afford it, it's highly recommended. I don't know that I would say it's mandatory, would you?
No.
I would not. But if you can afford it, I would do that. I think it's more important, this is my opinion from experience, is to separate search from content and content from other dissimilar SLA like site collections.
Yeah.
But if this is a perfect world, more of a perfect world design here, you can see with lots of LUNs and millions of pounds worth of storage. Not me.
Not me.
That's not good because maybe that is me then. I know, it's orange. So let's talk a little bit about IOPS, and here's what it's not. That's Cyclops, in case you were curious. It's not IOPS. IOPS is how many I/O operations per second. So how fast can I get data in and out of a hard drive or a disk? Mostly today we're talking about RAID, so an array of disks. And so it's really about how much content can I get in and out of the storage array. Very rarely we'll be writing to a single disk, less for fault tolerance and probably more for performance. So to give you an idea, we pulled some just averages across wherever the local computer store is today. And the 7200 drive was only about 75 or 100 I/O per second, which is pretty slow. If you think about that, search requires 3,500 IOPS minimum. You would have to have a storage array of at least 35, is my math good?
Yeah.
35 7200 drives to meet the minimum search requirement. So that would be a lot of disks. And it wouldn't matter if they were terabyte disks. See, it has nothing to do with the size of the disk. It has to do with the speed of the disk. SharePoint cares more about the speed than the size. And you'll see on the upper end here, 15K SAS, you're still in the 210 range. So modern fiber channels can get in the, I don't know, what is it now, 300 or 400, but they're expensive. But I think what you'll notice here is no matter what you do, it will take an array to get the type of throughput much of SharePoint's going to require. As we think about arrays, you can't just take a RAID 5 with 5 disks. I see it's really common. We take 5 disks, and if it's 200 IOPS per drive, we do the math. So 5 times 200 is 1,000. Very good there. Yep. That's where
we haven't got any swag, sorry.
Sorry. I do, actually. Here, I'll give you a book afterwards. Come find me. So that's where there's a thing on your instructor encouraged participation. But you'll see here that we have a 57, we multiply it by 0.57. We have a 43% penalty in a RAID 5. So you're actually only getting 570 IOPS out of that 1,000. Does that make sense? You don't just add it up, and hot spares don't matter. So you drop a hot spare in here, don't calculate that spindle into your total throughput. You'll see here RAID 10, if at all possible, RAID 10 is what we like to use for the service application databases. Many times, content databases, we can go RAID 5. We don't have near the churn on RAID 5 as we do on service apps, so we like RAID 10. You could go 0 plus 1, and I suppose we could argue that round or flat if we had to. But arrays always have a penalty, and this is a basic formula up here on the screen, and you'll have this in your decks. What about snapshots? Do you have customers use those a lot with Microsoft?
Well, basically, snapshots are great, but bear in mind, as we know, that it's only a SQL Enterprise feature. And I basically recommend that you do snapshots if you're doing content deployment. Okay, so you can actually activate that feature in SharePoint 2.10.
And if you're trying to do snapshots on the storage frame itself, it could also be substantial.
Yep, correct. Yep.
So just a couple of examples here. Of service application and the types of throughput you need. And so the crawl is 3,500 to 7,000 with the property database at 2,000. Key into that 2,000 IOPS, because if you were to go through TechNet and MSDN and look at essentially the requirements for disk, 2,000 is essentially the minimum. There's a few that say 700 or 800 like central administration. But essentially 2,000 IOPS is what the disk needs to be on the back end of SQL. That's the type of speed that SharePoint is looking for when it's consuming SQL. You'll see also the usage database is quite high, and it can get out of control as well.
Yeah. So basically the usage database is really about the second database that you need to worry about. Now the reason that it kind of varies, it depends on what type of diagnostic logging you're trying to do and how much of that you've actually turned up and enabled, etc. on there. So it's another database that can get quite high in the IOPS requirements. So just be aware about that, once again, as to where you lay that out, where you configure that, and where you put that.
With content databases, there is a little bit of engineering. We need to have some forethought into how we're going to architect this on SQL. If we were to put a content database on the same spindle set as, say, for example, the crawl database, we could see very bad performance in that content database. So just having a single, so a lot of times I have actually seen, so it is me, what is the luck? If we have two LUNs mounted off the same array, we haven't helped ourselves by having two LUNs at all, have we, for performance? Because we're still off of that spindles. We actually need to know where the drives are. So consider both the size and the speed of the disk. I would challenge that more often than not, we're limited by the speed of the disk and not by the size. Tell me about how I estimate IOPS you're at MCM and MCA. How do we do that? Because 0.25 to 4 seems like a pretty wide gap.
It is a pretty, but the key point about this is that it does actually depend, okay? So really what you've got to do is take some benchmarks, you do got to measure it, you then got to track it. It really comes down to your governance plan. So I'm wearing my MCA hat on this one.
What?
Your governance plan.
Oh, okay. And I'm assuming this is going to change over time.
That will change over time.
So monitoring, doing health checks, seeing which databases are used and not. So it will change over time.
Yep. So one of the things that you need to do as part of the sizing and actually determining how big are these databases are going to get, particularly from a content one, is trying to get some type of formula that get into place. So what we have got the standard formula which you can pull down from TechNet. That's available to actually go through there and do some calculations around it. So it kind of looks a little bit intimidating when you first look at it, but essentially it's actually pretty straightforward. What we're basically saying here is that we're looking at the number of documents that you're going to potentially have, how many versions of those documents you're going to have. Then it also looks at the number or the average size of those documents, and that basically gives you a core number. But then we need to add into that how many list items we're going to have for that. 10K, which is the amount of metadata that we've got with it, times the number of list items, plus the number of versions, plus the number of documents again. So if you kind of think about that, that's kind of going, whoa, where did all this come from? It's actually quite simple if you think about it. It's a document, and then how many documents are going to go into those particular list items and be associated with that. So you're trying to think, well, I don't actually know how many documents I'm going to have. Well, that's what you need to find out, and that's probably the key thing about it. But you're probably then thinking, well, how many versions am I going to have? I don't actually know. So what we've done within Microsoft is that we've actually gone through and analysed a lot of our data. And what we've found is that on average, it's about 2.2 versions per document that we're actually keeping. Now, the reason that this is important, if you kind of take a step back as to how SharePoint actually stores the data within SharePoint or within SQL Server, is that if you've got a version of a document and you've got 3 versions of that, you've actually got 3 different blob entries in the database of that. So SharePoint doesn't actually store the deltas between it. It actually stores the whole document again. So if you've got a 1 meg document and you've got 10 versions, you've got 10 meg, right? It's a bit naff, but that's the way SharePoint works. The other one around that is what's the average size of a document, okay? So once again, that needs to be analysis. I'll just come back and get to you in a second. So once again, we've done some analysis within Microsoft, and we found that the average size of a document is 220K, okay? 220 KB. So if you're trying to look at how do you actually do your sizing internally, those are some general ideas that you can use. Sorry, your question.
I wanted to ask about duplication content that you mentioned in terms of versioning. We have observed that when we implement remote block storage based on file stream, then what you mentioned about keeping the number of blocks
Okay.
related to versions is not true. That the size of database
Okay.
plus size.
Okay. So I'll try and paraphrase what you're making. So the observation or the point down here on the floor was that we've got RBS, remote block storage, and we need to take that into account, and some of these equations get a little bit wacky. Okay, now the reason behind that is RBS does not remove any of your constraints around how much data you can actually put in SharePoint. Okay, I want to make that point very clear. So we have got some guidelines around how big can the content DBs get. RBS does not remove that at all because things still need to come in and out of SharePoint. So we've got, for example, the 2 gig maximum file size. That still remains, doesn't go away. Now the issue you've got is that RBS does actually very, very much confuses your backup, restore, basically disaster recovery scenario. So a lot of the solutions and the vendors around that basically say keep more versions so you can actually go back, because that way it won't be flushed off the file system. And so, yes, you're right, you do need to take that into consideration as part of your overall sizing. Okay? So,
and obviously it changes if you know, the averages are great to know, but if you're doing a record solution or if you have a better idea of your versions and your file size, then by all means go with what you have. But otherwise, I think it's brilliant to know some industry averages.
Yeah. So what we're going to look at now is kind of change course a little bit and look at around high availability. So, people talk about high availability, but what does it actually mean? So what I did was I went out and went to my friend Wikipedia, even though I just discovered that 60% of the content is actually wrong. And they've come up with this lovely quote about a system design approach, an associated service implementation that assures a prearranged level of operational performance. Okay? Kind of blah, 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 blah. Okay? So what does it actually mean? A lot of people start talking around things around the nines. So we get 99% availability through to the 5 nines and through to the 6 nines. And if you kind of digest that back and have a think about it, what does it actually mean from an unplanned outage perspective? It basically means that if you've got, for example, 99% availability, you can only have an unplanned outage of 1.68 hours a week. And if you take that right through to the 6 nines, you've got 0.61 seconds of outage you can actually do. So the issue there is, how do we actually then go through an architected solution to meet these high availability requirements? Oh, there's the pointer. Cool. I get the pointer. So the other thing we need to start talking about then is, well, what actually really drives this? So the key thing behind this is that we need to start talking around things called RPO, RTO, and SLA requirements. So a lot of people kind of talk about these, but what exactly are these? The first one is the recovery point objective, which is your RPO. So that basically says that if we get a failure in this point of time, how much data can we actually, how much committed data can we actually afford to lose? And that's what our RPO is. Our RTO then is, from the point of failure, how long is it actually going to take before we're actually up and running again? And so these two things really, really drive what type of solution we actually need to put in place from a high availability and or a disaster recovery perspective.
What do most executives tell you is their RPO, RTO?
0 and 0.
That's right.
Okay. So
how many
when
people
you
here
hear
have an SLA? So you have an actual written down, agreed upon SLA.
Okay. How many people have RPOs and RTOs defined? Okay. Not as many. So it becomes quite critical. Being basically the service level agreements really define how many nines you require from a high availability perspective, whilst the RPO and RTO really define what type of solution do we need to put in place to actually ensure that we, how much data can we actually afford to lose or not lose, and how quickly do we need to get up in place. Okay. So what we've got from a SQL Server perspective is that we have got a number of high availability technology solutions that we've got there. We've got database mirroring, failover clustering, transactional peer-to-peer, even though that's not really a SQL Server thing, it's kind of out there, some organisations use it. We've got another one which is log shipping, and then we've got the old SharePoint and SQL backup restore. Now we're going to go through some of these. What I haven't got up here is the always on, which is part of SQL Server 2012, codenamed Denali. That's kind of like a hybrid between database mirroring and failover clustering. It kind of merges those technologies together. So if you kind of think about from a high always on, from a Denali perspective, it's kind of think of it and treat it as the same way as database mirroring. It's probably the best analogy. So the first one we're going to look at is failover clustering. Now failover clustering is actually not a SQL Server technology. It is actually a Windows Server technology. It just happens that SQL Server knows about it and can actually use the technology. So what it basically does, it provides us hardware redundancy at the server level, such that basically if we get a transaction that actually happens, do you love the little demo? It's pretty cool. Our demos are going to work in here, okay? No issues. And if we get a server that actually goes fail, because we're actually using the same disk subsystem below the scenes, we do the other transaction, we've failed over, and we're still up and going. So that looks pretty good. So if we get an issue, we're going to fail over as a unit. What's the downside?
We have shared disks. So part of the problem there is obviously if the disk fails, SQL's down. The upside is I only have one copy of my data. So as you'll see in this next slide in mirroring, go into technology like mirroring will double my storage requirements, or actually a touch more.
So if we get a subsystem outage using clustering, we've got a technical term which is you're screwed.
Yeah.
Okay. Okay. So hopefully that wasn't recorded.
No, I think I asked earlier. They said it was fine.
It was
in
fine.
England.
Okay.
Yeah,
So I said
UK,
you're screwed. Okay. So
it's cleared.
okay. So just be aware of that. So really, what that means is that failover clustering is really more of a high availability than a disaster recovery type scenario that you're trying to have, to work with that. The other thing too is that you do need a little bit of specialised skills, primarily from an IT pro perspective, less from a SQL perspective, and less from a SharePoint administration perspective. But it is quite easy to set up, particularly with Windows Server 2008 R2, doing my marketing plug. Okay, going for it. Now the other thing we can do is that you can actually have up to 16 nodes working with this as well, although you do need enterprise to go up to 16. So what that means is that you can actually have multiple nodes sitting in there. So most people configure this with only 2 servers, but you can actually go up to effectively 16 servers on that. Now, so from a SharePoint database perspective, now what we're going to do is that every time we go through one of these technologies, we're going to pull out which databases are and not support it from a SharePoint perspective, because there is a lot of misinformation out there, out on in the interweb around this. So from a SharePoint database perspective, obviously all databases are supported, okay, because it's using the same subsystem, and so unsupported is basically not applicable.
But the good news is you always have TechNet, which is 100% accurate. So.
Yeah, right. Okay.
I don't work for Microsoft, so I can say that.
Yeah, I probably won't after today either. Okay, so now we're going to look at database mirroring and looking at it from a synchronous perspective. So basically what happens here, once again the demo is going to work perfectly. What we do is that we get a transaction that happens. So basically what happens is it sends it to the principal, it then fires it across to the mirror before it commits the transaction. What it then does, it commits the transaction on the mirror. Okay, so it's committed. It then sends the notification back to the principal, which then commits the transaction on the principal, and that's the end of the transaction. So what this basically means is that we're making sure that every time something's written, we've got another copy somewhere else before we actually commit it back to the original place.
And I can have the principal in Auckland and the mirror in London.
No. So there are some very strict requirements around what's going to be the network latency between both locations. So basically what we say is that there's a 2 millisecond network latency round trip. So if you want to do database mirroring, you've got to basically have a very, very close look at your network latency speeds, and it's basically 1 millisecond from the principal, make sure I get it the right way, from the principal across to the mirror as being 1 millisecond, and then another 1 millisecond back. So what that means is that you couldn't set up a mirror based here in London and have your mirror based up in Edinburgh, as an example, because the electrons are still got to cover and you're not going to actually make that in time.
And that's just physics, speed of light on latency, right? So there's really no way to overcome that with bandwidth.
That's right. So just if you want to do mirroring, that's a hard requirement. 2 millisecond round trip between it.
So basically you're probably lighting your fiber or you're close to it.
Yep, very much so. So you could do one from here, it's like from this location to across the other side of the Thames will work as well. Okay. So the other way you can do it, that what showed you was what we call synchronous mirroring. The other approach is to what we call asynchronous mirroring. So we can get a slightly better performance on this. So basically what happens here, the demo is going to work perfectly, fires it off to the principal, it commits the transaction, it then sends it across to the mirror asynchronously, and that commits the transaction. Pretty straightforward. However, once again, there is that 2 millisecond or 1 millisecond network latency thing that we need to worry about. Okay? So we do need to worry about that. So it's committed. Okay, so if we kind of look at database mirroring, it's quite a cost-effective way. Now, the only issue is that traditionally DBAs don't know that much about mirroring. They, historically we've done a lot more work around doing clustering, so it can be a little bit daunting when you ask a DBA or a SharePoint person to come along and set up database mirroring. But it is actually quite straightforward to do, and in some ways it's actually quite a lot easier than actually setting up clustering. But the other thing we need to be wary about, though, is that it works at the database level. So what we have to do is that when we want to configure up database mirroring, we have to go up and actually configure this on each of the databases that we want to mirror. So there's a little bit of work and there's a little bit of process that needs to actually happen in there. So if you kind of think from it from a SharePoint administrator perspective, it's actually quite easy for us to go through into the central admin, create another content DB, or create another service application, which has got database associated with it, and hang on, I need to do something else behind the scenes such that I can actually mirror it. Okay? So you have to think about that to get some processes in place. Now also, sorry, yes, question?
Sorry, you're offering this up as a high availability for SharePoint. You can't mirror all the databases in SharePoint.
We're going to get to that. So the comment was you can't mirror all the databases for SharePoint, and we're going to cover that very shortly. Okay, thank you. So the other thing that happens too is that when you actually do a failover, you will get a slight hiccup when things actually fail over. Now the good thing is that SharePoint is mirror aware. So what that basically means is that the way that mirroring works, it kind of treats it from the perspective of saying, I'm going to fail over, but the application needs to know about this so it knows where to actually redirect itself to. SharePoint, the good news is mirror aware, which is why when you go into the central admin, you've got those funny additional things which say, what's the failover database server, which is good. But there is a little gotcha, okay? From a SharePoint perspective, if you want to get automatic failover, you do need a witness server. Okay? If you don't have the witness server, you're not going to get automatic failover on the outage. So, which databases are supported? So a gentleman in the front there said that there are some databases which aren't supported. Unfortunately, this is where I don't get to work for Microsoft anymore. The technical articles out there are actually wrong. All SharePoint databases are supported for mirroring, for synchronous mirroring. Okay, all of them, except for the unsupported. Okay, and I'll get to that. However, just because we've got all the databases being supported, there's some that are probably not recommended to do mirroring on, such as
Mirroring, I'll go with you.
So which ones do the high IOPS?
Crawl database.
Crawl
Probably one I
database.
would not want to mirror.
Yep, usage. Okay,
Usage database.
that's another one. Okay, you probably don't want to do it. There's also, I've come across just recently with one of my clients, I've had an issue with the web analytics databases, and that actually came down to not being at the correct patch level. Okay, so there's a bit of a fix on some of the latest patches on that. So just be wary about some of those. Now the patch for SQL was the latest patch on SQL. So the other one to be wary about too is that if you're using Power Pivot, that as an application is not mirror aware. So what that basically means is that if you want to get automatic failover, you have to put some alerts, etc., or triggers into SQL Server, okay, so it can do the failover for you as you would do back under 2007. Now I did say that all of the databases are supported apart from the unsupported, and where it's not supported is when you're doing remote blog storage. If you're using the SQL Server file stream provider, if you're using some of the other RBS providers that some of the vendors provide, then you need to go through, talk to them and get their actual feedback in there. And up there is the technical article which is wrong, which is hopefully going to be addressed. So I've been in contact with the product lead, product manager on this, and he's trying to get this updated, so we'll watch this space.
I mean, it seems as if blobs here cause as many problems or more than they solve for a lot of people.
Yeah, well, RBS is an interesting discussion, and to me, a lot of the time it actually comes down to what is the problem that you think you're solving with RBS. Okay, and if you kind of digest that back sometimes, the problem that you think you're solving is not actually the right problem. Okay, so you still got the database size restrictions. Okay, it makes your DR strategy and high availability strategy a lot more complicated. Okay, the only time that it kind of makes sense is that if you want to use cheaper storage. Okay, probably in like a record center or something like that. So go back and address the requirements. Okay, so log shipping. So basically the way that this works, it pretty much works a little bit along the same lines as mirroring. So what it does, it sends the transaction log backups to another server instance. So it sends the logs and they get reapplied to the other database server. Now the advantage about this is that you're not having to do a one-to-one like you are with database mirroring. You can actually send your log ships and do it to one-to-many. So this basically means that you could actually have different disaster recovery areas or different farms that you want to send it to actually have that. There's also no network latency dependencies on this. So if you wanted to do your DR farm up to, for example, Edinburgh, log shipping would have to be the way that you go with this. Okay? Because there's no network latency dependencies in there. So, basically a summary of that. One or more instances is a SQL Server, and it's more for a DR rather than a high availability type scenario, which is where you'd use your log shipping. So as to which databases are supported, once again we've got a lot of misinformation out there. Okay, and this is the list, which I've had approved by Bill Bayer, who's the product manager for SharePoint on this. So basically, we can do all the content DBs excluding the central admin. We can do the secure store, we can do the SharePoint usage, but once again, it's not recommended to do it. We can do the project server, we can do the Power Pivot, and we can do the web analytics, user profile, manage metadata, performance point. Now, the reason those are in a slightly different color is that this is where some of the information's been incorrect around this. These are the databases that you can actually log ship. So the ones that are unsupported are all the others. And if you're trying to work out which Technic article to actually look at, the top one is our evil one that we had before, which is hopefully being rewritten, while the bottom one is actually the one that's correct, which actually covers this correctly. You heard it here, and I don't get to work for Microsoft anymore.
Some of my favorite documentation for 2010 is in the capacity planning and performance section and in that DR section. So if you're looking for deep information that's generally very accurate, those are my preferences as a side note.
Okay, cool.
Non-Microsoft view.
Okay. So now we can actually do some multiple additional options on this. So what we can actually do here is that we can kind of combine a number of these technologies together depending on what we want to do. So we could, for example, do failover clustering. We could also do database mirroring to another site. So we've got our high availability. And we could also do log shipping to actually handle more of our DR type scenario as well. So once again, my demo is going to work beautifully. Don't you love that? My demos don't break. Ooh. Yeah, we can keep on going all day with that one. Okay. So kind of just to summarize those different technologies. So what I've basically got here is trying to show you what the different options are as to where you kind of fit into going back to your RPO and RTO requirements. So going along the bottom, we've got our recovery point objective, which is, as a reminder, how much data are we prepared to lose? How much committed data are we prepared to lose before an outage?
5 second rule.
Okay. How much data are we prepared to lose when an outage actually occurs? And the RTO is how much time it's actually going to take to bring it back up and going. So kind of sitting down in the bottom right corner is bottom left corner, is we've got synchronous mirroring and failover clustering. Now, I kind of group those together, but it really depends on what the outage is. So if you get, for example, your SAN goes out, okay, it's not really an RTO back at being 0, it could be days, okay?
Just be careful. I mean, we see clients who do a backup once a day. And that once a day backup, that means your RTO is about 24 hours.
Yep.
So you're willing to lose 24 hours of data. So just something to keep in mind. And that's why even with business or stakeholders, we do like to talk about RTO and RPO. You don't want to have to engineer to one standard. You really do want to be able to know both of those because it can decrease the complexity of your design.
Yep. And also just be aware too that the closer the numbers are to 0, the more expensive it's going to be as a general rule. Okay, because basically an RPO and RTO is 0 basically means no single point of failure anywhere. Okay, so as an example, on your SAN subsystem, have you got dual NICs into it? Okay, or whatever they are.
Yeah.
Okay, as an example.
I'll give you, recently we did a design and we spec'd a 2-hour RTO and a 4-hour. To go from 4 hours to 2 hours, double the price of the entire solution. So just to give you an idea. So it's a huge jump. I mean, executives always say, or stakeholders, it's 15 minutes. And so what I love to do is go put some rough numbers together and show them 24 hours, 8 hours, 2 hours, 15 minutes. And they'll go, 24 hours looks really good. So it's a fairly common scenario. So I generally would recommend not try to argue that at that point in time.
Yeah.
Go away, build a spreadsheet. They love PowerPoint, so get some PowerPoints in colors. Colors are good. And then get some of these big pound symbols or euros.
Yeah, that's actually quite funny because I usually joke about, you talk about the business users, they want 0 and 0. The chief financial officer wants, days and weeks. That's usually what happens. So this kind of gives you a feel as to what type of technology you should actually be going with, based on what your RTO requirements are. Now, I've also got peer-to-peer replication. Now, I haven't covered that. Now, natively, from a Microsoft perspective, we don't provide, or we don't give you anything out of the box for doing peer-to-peer replication. What this basically means is that if you want to do this, you're going to get the slides later anyway. So if you do want to do peer-to-peer replication, you're basically going to be looking at a third-party vendor or a third-party product in order to do that. My only bit of advice around that is make sure you get from them in writing that they are using supported methods for doing the replication. Okay? So they are going through the supported way, which is going through going through the API layer, and they're actually getting the data and getting it across correctly. Okay? Because I think we'll leave it there. Okay.
Yeah.
I'll be nice to our vendors.
Yep.
Okay. Just get it in writing that they are actually doing supported mechanisms. Okay. That will actually, if you get into a trouble situation, that you will still be supported in that trouble situation. Enough said. Okay. Then we get into log shipping and then backup, restore, getting into those high ones. Okay. Pretty straightforward. Okay. So what we're going to do now, since we're doing quite good on time, is kind of change track a little bit and talk about how we're going to get out and actually start deploying this. So we're going to look at things like SQL aliases, naming standards, creating databases. So SQL aliases. How many people use SQL aliases here?
Hey,
Okay.
that's good. It's a lot better than last year, by the way, which was a few people.
I actually want to see all hands up. Okay. Basically, SQL aliases is just something that you should just do out of best, recommended guidelines and practices. If you're not doing it, do it. It's pretty straightforward to do it. All you need to do is go in and fire up CL config, put in the aliases, put in the port number that you want, and you're away laughing. Now, the reason for that we recommend doing this is that it provides you isolation from where the application thinks SQL Server actually is. So if you need to move SQL Server around, or where you actually lay it out, all you need to do is update the alias. Okay, it's nice and easy. Now, I have seen some organisations go through and use doing DNS entries. Can you think of any issues with DNS entries? Put you on the spot.
We don't manage DNS, number one.
You don't manage DNS, that's one issue. The other issue too with DNS entries is that what happens if you've got a database instance? Okay, DNS only points to one location. So if you want to point it to an instance, a specific instance, you can't actually use a DNS entry. That's right. The other issue depends on how you configured up your DNS entries. Are you using C name records, or are you using A records? Okay.
C names are bad. I know that.
C names are evil, okay? C names are evil from the perspective of a Kerberos. So if you want to configure Kerberos, if you've got a C name record in there, you're effectively doing a jump to the C name, which is then pointing a record to another server, so you're actually doing another jump. So configuring up Kerberos to actually understand that and do the delegation through that becomes a whole lot of mess, becomes ugly, just don't do it. So even if you decide to go through and use DNS records, make sure that you're actually configuring A records. It will cause you a lot of, or won't give you a lot of anguish and pain later on if you go down that route. Okay, so pretty straightforward to do it, just do it. The other thing to think about too is that, as you start designing and architecting out your SharePoint environments, is trying to get some database naming standards in place. Ideally, we don't want to have GUIDs there. Now, the reason we don't want GUIDs is that our DBA friends hate seeing GUIDs in the database names. The simple reason is that they don't know what they're for. So you go through there, You open up SQL Manager, have a look in there, and you've got all these GUIDs, and you go, which database does this? Can I delete that one? I'm not sure if I can actually do it. So basically, you need to start thinking about that. So the guidance here is really, trying to start thinking up front as part of architecting at your farms about getting an actual standard in place. So what I tend to do is that I break the databases up into 3 different criteria. I look at it from a configuration perspective, a content perspective, content DB perspective, and then from a service application perspective, and try and get some type of naming standard around that. So some other things to consider when you're actually designing your naming standards are, think about having multiple farms and think about having multiple environments. Okay, because you may actually only install one farm initially, but what's to stop you from putting in like a services farm later on, or having another farm, used elsewhere?
Consistency is probably one of the best things you can do.
Yeah.
And don't name databases for the first application that goes on the farm. Right? This is a new HR farm, so it's going to be WSS HR portal, and then you see 3 months later, oh, well, our naming's off. So we can go back one day and we can script something that was named consistently, but arbitrarily named is pretty hard to script around.
Exactly. So as you would have probably seen it from the first sessions that we had this morning, was that they did actually have a database naming standard put in place. So it's ISC content as an example, so we know that it's part of this conference. Okay. So the other issue that often comes up is who actually creates the databases? Is it the DBA or is it the SharePoint admin? Okay. So this becomes a bit of an interesting discussion and a bit of an interesting debate. Who actually does it? So a lot of the times the DBAs go, hell no, the SharePoint admin is going to go anywhere near my database server. I'm not even going to give you log-on rights to it, let alone DBO or DBA creator rights on that. So that becomes a bit of a, what actually happens in those situations. So basically, when you go to install a farm, the SharePoint account that you're using for doing the installation does need to have a SQL logon with DB creator and security admin rights. So what it does behind the scenes then is, because it's got those rights, it can actually delegate down the different permissions down to the farm account, which it basically gives it DB creator, security admin, and DB owner rights on those particular databases that you've got there.
If you have a conversation with the SQL DBA, talk about how if we create as a SharePoint admin, we're then going to tell you what databases we created, and then you can go build your maintenance plans and take control of those. It's going to make their life easier. So, if you can have that conversation, it does simplify it it just simplifies it actually.
Yeah. But it is critical, just on that second point about the farm account, the farm account does always need DB creator, security admin, and DB owner. I've seen a few situations where the DBAs have actually gone in, pulled those rights out, and they couldn't work out why the farm was no longer functional. Okay? You've got to make sure that those rights are actually in there. Now, if you go with the other approach, which is that the DBA goes out and creates all your databases for you, they still need to go through and configure the farm account. So it's a security logon, like I said, with DB creator, security admin, DB owner. But if you do that, the issue then is that how are you actually going to do your installation? What it means is that you're going to have to start scripting this. So if your DBAs want to create your databases for you, you're basically being forced down to a PowerShell install mechanism. So you can actually get to those and name them. Cool. So what we're going to do, what is the time?
We have 6 minutes.
I have 6 minutes?
Yes.
What I'll do, this is going to take longer than 6 minutes, okay? Because what we're going to basically do, I'll quickly walk you through the demo, which we'll do first thing as part of the start of the next session. What we're going to do is go through, create a content DB, then we're going to move it around and then set up mirroring on it. So it's going to take probably about 10, 15 minutes to do.
And the next session is going to be basically all demonstration.
It's going to basically be all
the
demo.
next session is going to be demonstrating everything we just talked about, essentially.
Apart from the cool demos which didn't break.
Yeah.
Okay. So since we've only got 6 minutes, we'll go through summary, which is basically what we've talked about. So what we've done here is looked at designing, getting this subsystem right, looking at the SharePoint databases, critical around the RPO, RTO, and SLAs, getting those to find out, and just around deploying, a little bit around deploying. So what I suggest we do is that we open it up for questions and hopefully answers.